excuse me, there is a recording. Ideally, it's best to check the recording of the current year because they get a little bit better every year, but there's also the recording of the past years. All right. And okay, here we go. Number one. Now, number one is good reasonable reasoning. Good reasoning. But it's also good preparing you for your future class, which will probably be an algebra class one way or the other. Okay, so it says A is 20, C is 0. Let's go ahead and make this again. So we have 4, 1, 0, 3, 6, 2, 5, -1, and I almost judged correctly 7. So it says A is 20, C is 0. All right, so we are looking for a pattern. Okay, so I would like everyone to guess. That one is D. Everyone guess. Look for the pattern and type in, please. Oh, just a reminder, you can get extra credit for attending this Zoom session. Please type answers into the chat and participate. It is good for your brain and earns you 5 extra credit points. So everyone make a logical, educated guess. Awesome. What number goes there? Okay, awesome. Oh, you guys got this. Okay, see, that also gives me feedback. That is 15. Yeah, so the rule is multiply by 5. And you guys got it so quickly. We're going to go, we're not going to drag this one on. Or the equation is y equals 5 times the x. That's how we write it algebraically. So we go through, notice horizontally, all of the numbers are mixed up. They're randomly put in there. But vertically, there's a pattern that you take the top number and you multiply the bottom number by 5. So 1 times 5, 4 times 5 is 20. 0 times 5 is 0. 6 times 5 is 30. 2 times 5 is 10. 5 times 5 is 25. -1 times 5 is -5, and 7 times 5 is 35. The interesting thing is the numbers look all mixed up. If I were to graph them, they would form what shape? A U, a line, a circle, just all mixed up. Would they not be in a shape? Would they be random? What do you think? Okay, you don't necessarily have to guess this one. Anyone feeling brave to guess this one? If I were to graph them, they would look like that. Yeah, a line. Very good. They would actually line up. Okay, so there's that one. Okay, now this is important. Can you see the fact that 0 was 0 told us it was probably not an add or subtract problem? Yeah, it was probably a multiply or divide problem. So that's what's important there. Okay, let's do this one again. So we have x That's an X. 4103625 -1 7. I went too far this time. Okay, so ignore this. Okay, it says that A is 7 and F is 5. So under the 2, sorry, my handwriting's so bad. Okay, do we see the rule for this one? Awesome. One of you has already told me. Yeah, anyone else see the rule? All right, good job. Okay, so everyone, please guess B, excuse me, is going to be equal to what? What am I going to put there for B? Yeah. 4 C. What am I going to put in there for C? All right, you guys are great. So the rule is adding 3. Yeah. Or y equals x plus 3. So notice when we add, we have to put the plus sign. But when we multiply, we just put them next to each other. There is no multiplication sign, right? A coefficient and a variable next to each other implies multiplication. So we are going to add 3 to these terms. Okay. Yeah, not too bad. We are going to move on to the next one. Okay. Oh my, I'm having all sorts of issues today. Okay. So my first question is, what do I do to the coefficients? Oh, okay. So if this is confusing and you want to see that box again, we can go back to that. Okay, those boxes. So now we're going to move on to the next, or are the exponent ones are confusing. Okay. Yeah, you know what? Hold on. Okay, I'm glad you clarified that. Okay, so the exponent ones. I've noticed for those of you that have taken the exam so far, this tends to be an area we need to talk about more. So what do I do with the coefficients? Add, subtract, multiply, or divide. And some of you have already told me. Oh, no, we are going to multiply. Now that's confusing because 2 plus 2 is 4 and 2 times 2 is 4. You multiply the coefficient. Okay. And now what are we going to do with the exponents? Yeah, we are going to add the exponents. Okay, multiply the coefficients, add the exponents. Yeah. Okay, so let's add another one in here. Okay, can you guys type that in? And to get an exponent, you're going to type this. For example, this would be 4n exponent 6. Yeah, can you guys type that in? Oh, and online exam, this is a video. Okay, so, oh, sorry, how about this one? Yeah, Awesome. So we are going to multiply the exponents. Sorry. Ooh, my bad. Multiply the coefficients, add the exponents. Yeah, multiply the coefficients, add the exponents. Okay, now, how about this one? This exponent applies to both the coefficient and the variable. So we're going to apply it to the coefficient and apply it to the variable. Kind of like distributive. If you wanted to say distributive, you could, to me, not necessarily out there in the real world because it's kind of not distributing, but okay. So technically there's an exponent of 1 and multiply that. So you, oh, okay, wait. Now let's talk about this. This variable right here has 2 exponents. Awesome. It has superpowers. Base to the power, superpowers, right? Multiply. So when it has one base and 2 powers, you multiply. So this is x to the 12th, correct? Now, 3 cubed is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Or on my calculators, you go 3 to the 3rd power and you would get 27. Yeah. Now, if you're coming in to take my exam, remember to, we could have a little talk about where all the buttons are on my calculators. Okay, 27x to the 12th. So really quick. Okay, a little messy, but the first one is x to the what? Is it too messy? X, what's the exponent? Oh, let's do it again. Okay, x to the, are we going to add or multiply? Does it have superpowers? No, we are going to correct. Add. Yeah, but the second one has superpowers. Okay, anyone a Percy Jackson fan? Yeah, this is like the big 3 for Percy Jackson, if you're a Percy Jackson fan. Okay, so this is x to what power, correct? This is x to, all right, looks good. Yeah, keep them coming. How about everybody type in x to what number? There you go. Yeah, and you can direct message me x to the 28th. Yeah, do we see the difference? When we have 2 variables and 2 exponents, add. When we have superpowers, multiply. 1 variable, 2 exponents, superpowers. Yeah? Okay, awesome. Now, something next. Okay, speaking about Percy Jackson and Greek people, Greek gods. This is Pythagorean theorem. theorem. Okay, so this is Pythagorean theorem. Now, there are some things in geometry you will never see again, right? Side, angle, side, never see again, probably. Even if you take a million math classes, never see again. Pythagorean theorem, yeah, you're going to see it. Like it just kind of shows up just here and there. Okay. Or if you are doing something with wood, it might show up, or welding, it might show up. Pythagorean theorem is a keeper. Okay. So here's Pythagorean theorem. Side squared plus side squared equals hypotenuse. Yeah? Okay. Ah, nice. Nice, nice. Okay, but first, my math joke. So, there was a little old lady who lived in a shoe, and she put her she put her stove way up high. Okay, so she had a pot of water boiling way up high. Yeah, so here's her little house. Here's her shelf. Here is her little stove up on the shelf. Here is the pot of water, and here is steam coming out. It is not a low pot. So this pot down here is not being used. This is a low pot, not being used. You ready for the punchline? That makes this one. What are we going to call this one? Yeah? The green one, low pot, not being used. The pink one is high pot in use. Yeah, hypotenuse. That just made your day. Yeah? Maybe not? Okay, going away. That needs to go away. Okay. High pot in use. Over here. Okay. So this is what we have to do. We're going to follow the order of operations, parentheses, exponents, multiply, divide, add, and subtract. So we have to follow those, and you work backwards through the order of operations to solve. Okay, we're ready to start. So correct. Someone said this like 3 minutes ago. 6 squared plus 8 squared equals x squared. You with me? Now, one thing I forgot to do. Let's label these. How do we know which one goes alone? Notice this is the biggest. This is across from the right angle. Yeah, across from the right angle. So go to the right angle, shoot the arrow. This is the hypotenuse. Okay, so the hypotenuse must go alone. The two sides, or sometimes we call them legs, the two sides squared are together. Yeah, the hypotenuse is the one. It's usually the biggest unless your triangle is drawn poorly, but it is always the one across from the right angle. Okay, so now according to the order of operations, what do we do next? Parentheses? No. What do we get? Yeah, there we go. 6 to the second power, exponents. 6 squared is what, my friends? All right, 36. 8 squared is what? Thank you. 64. Let's go, Zoomers. Let's see some more answers in there. Awesome. Okay, I'm impressed because you are doing Zoom on your phone, I believe, and still participating in the chat. So thank you very much. 'Cause it says it's your phone, but I don't know. Okay, equals x squared. Now, according to the order of operations, what do we do next? Oh, you are awesome. That is great. Maybe I don't do Zoom on my phone very much. We are adding them together. So 36 plus 64 is 100. Now, okay, do you see that we are, thank you for participating. Yeah. Do you see that since they are together on the same side, we are not isolating a variable. What we're doing is combining like terms because they're together on the same side. Okay. So now let's take a look at this. I need to do an inverse operation to solve this equation. Ah, ding, ding, ding. You're good. Yeah, I want everyone. Come on, Zoomers, everyone. Is it add, subtract, multiply, divide, square, or square root? What do I do to both sides to undo the x squared? Awesome. Keep it coming, Zoomers. I need to isolate the variable and get it completely alone. Yeah? Add, subtract, multiply, divide, square, or square root. So let's look at it disappeared. So let's look at this. Let's talk about squared. 5 squared goes up to 25, correct? Square root of 25 is how much? 5. Okay, what do you notice about squared and square root? Yeah. Now, I haven't necessarily given you a word to describe this, but what do you notice about squared and square root? 5 squared goes up to 25. Okay, kind of. Squaring is multiplying by itself, and square rooting is saying, what did you multiply? Not really divide, but okay. Okay, this is good. This is good. We're working through this vocabulary. Can you see that these are opposites? And you're thinking, I had no idea what you were looking for. Okay, that's fair. Now, can you see that they are opposites? 5 squared goes to 25. 20 square root of 25 goes back to 5. So now we have some vocabulary, or they are inverses. Okay, and yeah, multiply and divide are kind of in that combination, but square root is the opposite of squared. So square root of 5 squared. Okay, let's talk about this. Square root of 5 squared is, yeah, are you thinking? Are you ahead of me? Yeah, you're one step ahead of me. Is that the square root of 25? Are you with me? And the square root of 25 is an outside 5. Do you see what's happening? So squared canceled square root, bing, 5 pops out. Yeah, do you see that the squared is canceling the square root because they are opposites? They are inverse operations. Okay, so team, what is the square root of 7 squared? Bing. Yeah, Zoomers, type it in. Not quite. I love that you can type in on direct message. Okay, one of you is correct, one of you is not. I only have 2 votes. Come on, Zoomers. Take a guess. Okay, I'm going to tell you this one and we're going to do another one because I want everyone piping in. So square root cancels the squared and we get 7. Yeah, there you go. Yeah, okay, we're going to do another one and I want everyone in. Square root of 161 squared is what? Do, 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 do. Ding, ding, ding. Correct. Yeah. More Zoomers. Be bold. Take a guess. Type it. All right. There's another good answer. Type it into direct message. No one will know if you're right or wrong, except me. And I need to know. I'm like your doctor. Yeah. I need to know if it's wrong. Okay. Square root cancels with squared and we get bing 161. Okay. Do we see that the square root is canceling the squared? And the 161 pops out. So we're going to do one more. Square root of 10 squared is ding, ding, ding. Yeah, more Zoomers. And don't forget you can get food over there. I don't know when though. Ding, oh, I see lots of Zoomers. Ding, ding, ding. Square root cancels with squared. Bing, 10 pops out. Okay. So now take the square root of both sides. Square root cancels with squared. Poof, X pops out. Yeah, are you with me that the X is going to pop out? Because the square root is the inverse of squared. Square root of 100 is 10. We are done. Yeah, Pythagorean theorem. Okay, let's do another one. Okay, let's be a little more careful and let's label the hypotenuse. Oh, thank you. Okay, awesome. That's what I like to hear. And that's why you guys participating actually makes it easier, even if your guesses are wrong. Okay. So step 1, put an H on the hypotenuse and type in which one you identified as the hypotenuse. Okay, so put an H on the hypotenuse on your paper or your cami, whatever you're doing, and then tell me what you chose to be your hypotenuse. Ding, ding, ding. Yes and yes. Yeah, more Zoomers. Let's go team. Take a guess. Even if you're wrong, it's going to be good for your brain. I'll give you a hint. Go to the right angle and shoot an arrow. And the arrow will hit the hypotenuse. It's also the longest. Yeah, hypot in use. Also the longest. So shoot the arrow, put an H for my hypotenuse. The 13 is the hypotenuse across from the right angle. Okay, Zoomers, write your equation. So that makes this side and side. Side squared plus side squared equals hypotenuse squared. Okay, careful. Careful. X squared, right? Did you see how this time it's a trick? Last time, X was the hypotenuse. Okay, or you could say B. This time, X is a side. Do we see the difference between 4 and 5? X squared plus 5 squared equals 13 squared. Please excuse my dear Aunt Sally. Okay, team, what's next? parentheses, exponents, multiply, divide, add, subtract. Ding, ding, ding. Okay, x squared, we cannot do anything. 5 squared is 25. What's next? 13 squared, thank you, is 169. Now, 4 and 5 are different. Yeah. Now, the 169 and the 25 are not together on the same side. Yeah, do you see the difference between problem number 4 and problem number 5? Problem number 4, they were together. Problem number 5, the 169 and the 25 are not together. You cannot combine them across that wall. Okay, so we're not combining, we are isolating the variable. Okay, correct. By this time we are subtracting. Now, how come last time we combined like terms and this time we subtract? It depends if your two numbers are together on the same side or on opposite sides of the equal sign. Yeah. Okay. So x squared is equal to 144. Now, we're not going to go through the opposite of x squared again. We already did that. Now, I need the opposite of x squared. We're not going to talk about y. We're just going to do it. I need to isolate my variable. I need to cancel out. I need the opposite of x squared. What is the opposite of x squared? Ding, ding, ding. Square root. So square root cancels with x squared. Bing, x pops out. Square root of 144 is 12. Thank you, Zoomers. Okay, so x equals 12, which makes sense because we know the 13 is the biggest. Okay, kind of surprised 12 is that big, but it's actually a perfect Pythagorean triple. 5, 12, 13. Perfect Pythagorean triple. And then this one, the 6, 8, 10 is another perfect Pythagorean triple. The other ones are going to come out to be square roots, not decimals, square roots. Okay. So acute, obtuse, or right. Step 1, we're going to label which one is the hypotenuse. Notice we don't know this angle, but this is our guess as to the hypotenuse. And we're guessing 15 is the hypotenuse because the hypotenuse is always the what? Biggest. Thank you. The hypotenuse is always the biggest side, the longest side. Okay, so let's try this. 11 squared plus 12 squared. Is it, I don't know, is it equal to 15 squared? Okay, so please excuse my dear Aunt Sally. 11 squared is 121. 12 squared is 144. Equal to 15 squared is, thank you, 225. You know what? Some people do know how. Oh, okay. So how are you typing it in? For me, for Zoom, I think sometimes we just do a V. So like square root of 25 would just be V25. Some people know how to get the square root sign because they appear in the chat and I don't know how they do it. And they also do squared, and I'm very impressed. Okay. So are we okay so far? Okay. So add them together. 265, is it equal to 225? So is this right, acute, or obtuse? We can eliminate one of those. Since they are not equal, then this is not, yeah, it's not a right angle. Can we see that it's not a right angle? Because it's not equal. So is it acute or is it obtuse? Oh, careful. Okay, now this is where, okay, I love it. I love your guesses. But if it was a right angle, okay, so this is the hardest part right here. Okay, this is the hardest part. This is our hypotenuse. Is the hypotenuse too big or too small? You have to know which, you're actually right. You have to know which one to look at. Our hypotenuse, right? H with quotes. Yeah, can you see that we're looking at this one? So our H with quotes is too small. You look at your H with quotes, therefore acute. Yeah, so you got to be really careful. This is how much it should be because of Pythagorean theorem. And this is how much we've got. And our H with quotes is too small. Yeah, acute. Okay, so let's do this one. Step 1, label your H. And we're going to call it H with quotes. Yeah, which one is the H? Okay, so it's always the largest. This is our H with quotes. We don't know if it's a hypotenuse because it's only a hypotenuse if it's a right triangle. Next, Pythagorean theorem. 5 squared plus 12 squared equals question mark 15 squared. The one before was acute. Yes. Okay. So 25 plus 144 is equal to 225. Thank you. Okay, 125 plus 144 is 250, 169. Wait, what? 169. Wow, last year I reversed these digits, but it doesn't matter. Okay, is 169 equal to 225? No. So it is not a right triangle. Okay, so this is my H in quotes. My H in quotes is too big. Yeah, it sounds like the 3 little pigs. It was too big. If my H in quotes is too big, you guys are getting the hang of this. Awesome. It is obtuse. Now, I'm the only one that says if H in quotes is too big, it's obtuse. This is what the world says. It's obtuse because A squared plus B squared is less than C squared. That means the hypotenuse is too big. So that's what this means. Hypotenuse is too big. Yeah, you getting the hang of this? And A squared plus B squared is greater than C squared. It's acute. That means hypotenuse is too small. So that's kind of the formal real world definition, but I like to call it H in quotes is too big, H in quotes is too small. Okay, next. Step 1, label your hypotenuse. The largest side is our potential hypotenuse. Next step, side squared plus side squared is equal to hypotenuse squared, or potential hypotenuse squared. I'm getting horrible clicking. I'm thinking it's my headphones, and you guys aren't hearing horrible clicking. Oh, wait, it's gone. Okay. Okay. Yeah, we're ready for the next step. Please excuse my dear Aunt Sally. Do your exponents. 9 plus 16 is 25. Ding, ding, ding. Thank you. And how much is 9 plus 16? Combine like terms because they're on the same side of the equal sign. 25 is equal to 25. Ding, ding, ding. This is a correct right triangle. And it is a Pythagorean triple. 3, 4, 5 is a Pythagorean theorem. Triple. Yes, it's a right triangle. Okay. Now, that's if the directions say, is it acute, obtuse, or right? What if the directions say yes or no? Oh, you know what? We're going to come back to these. I think you're going to find these are super easy. We'll come back to those at the end. Let's go to the next one. We need to start simplifying the square roots. Okay, what if you get a number that is not a perfect square? Okay, now it's a good thing you're here with me in the Canvas quizzes. Now, I realize everyone can either type this into your Casio calculator, or you can photo math. We all know that photo math's out there, right? You can photo math it and get the answer. But in the Canvas quiz, it's going to ask you to split it into the biggest perfect square. Sorry, my horrible handwriting. So you're going to take, oh, wow, you're good. You're going to take 50. No, we are not approximating. I realize in your previous classes, you may have approximated, and you're right. If we got a decimal, it would be very close to 7. Okay. But what we're doing is not an approximation, simplifying the square root. So in the Canvas quiz, it's going to ask you 450, what is the biggest perfect square? And what are the leftovers? Leftovers. Okay, so we're going to go to something called the chart of factors. And we're going to look at the number 50. Okay, and when you come in to take your test, if I forget to give you a chart of factors, you're going to remind me to give you a chart of factors. Okay, the chart of factors, 50 times 1 is the first one, will give you all of the factors of 50, not the prime factors, all the factors, the list of factors. Okay, so let's go back. Oh. Okay, so we see that we have 50 times 1, 25. We'll do it this way, sorry. 1 times 50, 2 times 25, 5 times 10. We got that from the chart of factors. Those are all the factors of 50. Now, what are our perfect squares? Okay, one of those is a perfect square. Which one of those is the biggest perfect square? Is 5 a perfect square? No, that gives me a decimal. Is 10 a perfect square? No. Is 2 a perfect square? So do you know what I mean? If you took the square root of 5, you would get a decimal. Yeah, those are not perfect squares. Let's go look at this chart again. Okay, sorry, this is sideways. I have one for you guys, not sideways, somewhere. Take a look at these. These are the perfect squares. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. So 25, if you tilt your head, can everyone see that 25 is a perfect square? Because the square root of 25 is 5. Are you with me, Zoomers? Yeah, do you see where I'm headed? If I want the biggest perfect square, 25 is in my list of perfect squares. Okay, split this into the biggest perfect square. So you would type square root of 50 25 is the biggest perfect square. Square root of 25, and you're just doing V's, square root 2, right? 25 is the biggest perfect square. 25 times 2 gives me 50. Are you with me? Or do we have a question? Yeah? The biggest perfect square and the leftovers. So now we simplify. What is, Zoomers, the square root of 25? All right, 5. And then you bring the leftovers down. There you go. As usual, the first one took a very long time. Okay. So number 12, I go to the chart of factors and I see that 48 is 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So the Canvas quiz, it's not going to just ask you for the answer. Oh, you're fast. It's going to ask you for the biggest perfect square and the leftovers. Yeah. Now let's just circle in gray all the perfect squares. 4 is a perfect square and 16 is a perfect square. Do we have a question? Is 24 a perfect square? Oh, let's check. Let's go to the chart of factors. Is 24 a perfect square? No, that's not on my list. But 4 is a perfect square and 16 is a perfect square. Yeah? Okay, so 16 and 4 are perfect squares. Now, if you need a chart of factors, next time you're in here with me, I'll give you one. Now, we're not gonna put 16 and 4 together, are we? We're gonna put the biggest perfect square and the leftovers. Yeah? So I'm gonna choose 16 and 3. 16 is my biggest perfect square. 3 is my leftovers. So 16 and 3. You with me? Super important. This is another thing that you will use in all future math classes. So what is the square root of 16? 4 square root 3, or 4 square root 3 typed in. Okay, let's talk about where the 3 came from. So we know where the 16 came from. So according to the chart of factors, once I choose the 16, the 3 goes with it because 48 is 3 times 16. Yeah, so you choose the 16 and the 3 has to come along. Okay, 16 times 3 equals 48. Done. So square root, yeah. So you could do square root of 4 squared, and that would be 4 square root 3. Nice. Yeah, so it's kind of practicing. Yes, that is perfect. Okay, let's do this one. Okay, so I need a factor of 200 that is the biggest perfect square. Okay, you know what, team? This is what we're going to do. Number 14, do not do. 16, do not do. Okay, 13 is on your own. 15 is on your own. We're going to do 17, and then if you need to go, you can go. These are on your own. My horrible handwriting. Okay, so if you can stick around, we will do all of those for you. Now, this is an isosceles right triangle. So let's draw this here. Isosceles right triangle. If A is 5, yeah, we're going to say A is 5. And it's isosceles, this A is also 5. So how can we find C if I know it is a right triangle? We're going to do Pythagorean theorem. So 5 squared plus 5 squared equals C squared. Okay, please excuse my dear Aunt Sally, do your exponents. 25 plus 25 equals C squared. Notice I have, how many 25s do I have? 2 25s, right? Can you see that I have 2 25s? Foreshadowing, that'll come back later. Okay, add those together, combine like terms. Oh, sorry. 50 is equal to C squared. Times 2? Oh, careful. Now, the opposite of squaring is square root. You are so tempted to cut that in half. We're not going to cut it in half. Yeah, you with me so far? Square root cancels with the squared. Bing, C pops out. I need to simplify the square root of 50. How do I simplify the square root of 50? Not a decimal, simplified. Okay, we are going to split it into the biggest perfect square and the leftovers. So the biggest perfect square is 25 and the leftovers is 2. I got that from the chart of factors. Okay, which one of those can I take the square root of? 5. So this is 5 square root 2. Oh, that's interesting. 5, 5, and 5 square root 2. Huh, look how interesting. Only when it's isosceles does that little pattern happen. Yeah, let's do another one. How about 6? Okay, 6. So let's draw a little triangle. Isosceles right triangle. C is the hypotenuse. Because it's isosceles, if one side is 6, the other side is 6. Okay, let's solve for C. 6 squared plus 6 squared equals C squared. $36 plus 36 equals C squared. Notice I have how many 36s? I have 2 36s. Yeah. So C squared is equal to 72. So what is the inverse operation of squaring? I have to do the opposite to isolate my variable. To solve for C, I do the opposite of C, which is square root. Square root cancels squared, poof, C pops out. And now I need to simplify the square root of 72. Oh, very careful. Okay, so we have 9 times 8. Let's look at the chart of factors. 72, 9 and 8. There's a trick. Here's a perfect square. Hard to see. Is there a perfect square? Okay, yeah. Thanks for coming. Okay. Is there a perfect square bigger than 9? Up. So you need to memorize that 72 has a perfect square bigger than 9 because everyone's comfortable with, oh yeah, 8 and 9. Nope. There's one bigger. Yeah. So 36 is the biggest perfect square and 2 is its leftovers. Okay. Now with this one, the cool thing is, oh, look, it was right there. 2 times 36. Okay. So I have the biggest perfect square and the leftovers. Okay. What is the square root of 36? 6 square root 2. Okay, one thing I love about doing this on Zoom, some of you are more bold to ask me questions than you would be if you were in person. So this was using 36 times 2. I just got a question. What if I used 8 times 9? Okay, let's see if we still get the same answer. So we have 9 is the biggest perfect square times 8. Square root of 9 is 3, and we have 8. Now, are we done, or does 8 have a biggest perfect square? Let's go look at 8. Oh, dang, 8's got a perfect square in it. Yeah, can you see that 8 has a perfect square of its own? Okay, so let's go back. Okay, so square root of 8 is biggest perfect square times leftovers, which is 2 rad 2. Look at this. 3 times 2 rad 2. Yeah, see where I got 3 times 2 rad 2 equals 6 rad 2. Okay, do you see how much harder that is? That is way harder. So you want the biggest perfect square and the leftovers. Yeah, and confusing.
For this one, it only shows this page and this. Do I do only that one, or do I do the rest of these?
Ooh, I'm gonna have to look. You want to send me an email and I'll look at it? Okay. Okay, so that is it. Some of those right triangle ones you can totally do. If you need to leave, you can leave. I'm gonna keep working if you want to see all of them. Okay, but if you're gonna disappear, thank you for coming. And I'll see you next week. But I'm going to start working backwards, doing the ones that we skipped. Okay. Bye. Thanks for coming. Okay, let's take a look at this one. 36. We're going to have the square root of 36. Now, I'm going to break n to the 4th into n squared, n squared. Yeah? So what's the square root of 36? 6. Okay, let's look at the square root of n squared. Squared cancels square root. Poof, n comes out. Square root cancels squared. Poof, n comes out. 6n squared. Okay. 14. Now, 200 is not on the chart of factors. So we are going to look at our list of perfect squares and it's sideways. So I'm just going to do it here. 1 squared is 1. 2 squared is 4. 3 squared is 9. 16, 25, 36, 49, 64, 81, 100, 121, and 144. Okay. Now, what are the perfect squares that are factors of 200? Do you see one? That would be the biggest perfect square that's a factor of 200. Hint, look at the last 2 digits. Okay, 25 definitely goes into 200. There's a bigger one. Do you see it? Ah, ding, ding, ding. We want the biggest perfect square. Okay, so we're going to split it into the biggest perfect square and the leftovers. What is the square root of 100? All right, 10 square root 2. Okay, do you want to should we do these together or you're good? Is it a right triangle? The video people are probably hoping that you say, let's do it together. So for the people watching the video, let's do it together. So is this a right triangle? Step 1, put an 8. Yeah, as long as you can stay. That's awesome. Put an H for the hypotenuse, longest side. So this is not, it's kind of like the previous ones. The previous ones were more work. This is just yes or no, is it a right triangle? So to find out yes or no, if it's a right triangle, we're going to do Pythagorean theorem. Side squared plus side squared equals hypotenuse squared, and we're not sure. Okay, please excuse my dear Aunt Sally. Let's do exponents. 36 plus 64. Is that equal to 169? Okay, combine like terms. 100 equal to 169? No. Now, our hypotenuse is too big. We don't have to say that. We just say no, not a right triangle. It is obtuse, correct. So if I asked you acute or obtuse, you would say obtuse, correct. So we're just going to say no. Yeah, so these are easier. You don't have to make that judgment. It's just yes or no. So this one, we're going to do this really quick. This is the H, longest side. 6 squared plus 8 squared equals 10 squared. $36 plus 64, question mark. Is it equal to 100? Combine like terms, is 100 equal to 100? Yes, it is a right triangle. And we are done. That was long. We went really slow over some of those problems, but hopefully going slow helped. Okay, thanks for staying. Any questions for me? Bye-bye. Thanks for coming and thanks for staying. You're awesome. Have a good day.